All right, welcome to week 2 of Chemistry 350, Chemical Literature. This week we want to focus on writing a methods section that would be not like your laboratory notebook, but we'll talk about that again too, but like what you would see in a peer-reviewed journal article. All right, so there's 3 ways really you can represent methods. So last week I gave you a procedure, which are the instructions that are written as commands, like add 3 milliliters of ethanol to the solution. Their steps are usually numbered. The materials are listed separately typically, and the instructions are very detailed so that others can repeat and follow the experiment. The lab notebook differs from that in that it's written in past tense to reflect what you actually did in the experiment. It can also be numbered steps, so you can put, instead of add 3 milliliters of ethanol, you would put I added 3 mils of ethanol to my solution. It can be written in both the first person or the third person or a combination of those two, so it can be active or passive. Usually it's very descriptive and contains details about what you did in the experiment. So things like color, what the reactions look like, did they bubble? You'll put your calculation details down there and write out your formulas to make sure that you have all of those details in the laboratory notebook. The laboratory notebook should also be detailed enough for others to repeat your experiment. And so you saw also the way that I like to do the laboratory notebook is to have the procedure, splitting my page, have the procedure on the left-hand side of the page, and then on the right-hand side in the right-hand column, I typically will either put a check mark in there, or if I do exactly what the procedure said, or I'll write how I changed it, and you can also put observations in there. I like that method just because it's very easy to follow what I've done. And the methods section then for a peer-reviewed journal article is written more as a narrative in paragraph form, and it's always written in the past tense, and it's always written in the third person. So you never say, I did this or we did that. Okay, so it's always using the passive voice. And we'll take a look at a short video that will introduce this concept as well. So the materials typically are embedded in the paragraph instead of listed separately like they can be in the procedure or in the laboratory notebook. And you'll explain in the paragraph what they're used for. And so we'll see an example of this as well. And then the descriptions also are detailed enough for others to repeat the experiment, although if they've been published previously, it might refer you to a previous publication. So here's an example of a procedure. Again, it's written in the command type of voice. Weigh out 1.500 grams of black tea to 4 decimal places and record the actual weight. This is just like the procedure that we saw that you did last week for the analysis of the Excedrin tablet. So the laboratory notebook then should provide complete records of procedures, reagents, data, and your thoughts that you would pass on to another researcher that would be reading your notebook. You should also have an explanation of why experiments were initiated, how they were performed, and the results. This provides a legal document inside the laboratory, so you can use this to prove patents and to defend your data against any accusations of fraud. So this is scientific. You also have a scientific legacy within the lab. You're not the only one that's going to be in the lab. We noted last time that your notebook actually stays inside the lab. You never really take it out when you're working in the lab. It belongs to the lab, not to you personally. And so all of your information that's in there will be the legacy that you pass on to the next person. And that's really critical and important when you might be a graduate student in a lab or a student an undergraduate student in the lab working for a year. You might not finish what you started, or you may only finish a piece of that research that's going on in there. And so you want to leave that document to the next person that's going to be able to come back in and say, oh, this person did all of these experiments, and here's the next logical step for me to start with. All right, and you may also leave reagents and things in the lab as well that you've made. So these should be clearly labeled and stored in appropriate places, and those storage places should also be noted in your laboratory notebook. Like you might say, oh, I made 200 micrograms of this DNA plasmid, and the plasmid's located in the -20 in this box. And then you'd be able to find it again, or somebody else in the lab would be able to find it and use that reagent. So a laboratory notebook is not a journal or a record of communications between you and other researchers, although you can have information put in there that you learn from communications. It's not a place to compile laboratory protocols or manuals. Typically, you do that separately. You might have a binder, a 3-ring binder, or you might do this electronically. And it's also not yours to take home. Okay, so that's again an important point about your laboratory notebook, that it belongs to the lab that you'll be working at. So there's different types of notebooks. I like to have one that's bound or stitched. The advantages here is that you don't have any lost pages, and it provides a legally stronger document than one that would be a loose leaf or a 3-ring binder notebook. But there are disadvantages. It's hard to copy, and it's not always logically organized, right? You might be working on 2 or 3 projects at the same time, and so everything's kind of written in there by date rather than by project, unless you have 3 different notebooks for your 3 different projects, which you could do that as well. It does always require references in there then to where the data is stored. So the loose leaf or 3-ring binder notebooks, they are organized by experiment, and the data is all stored together, but the sheets can fall out or be moved. So this isn't, in my opinion, the best type of notebook to have. So it's difficult to authenticate or stand up in a court of law. The electronic notebooks are also a new option, or a newer option. They're easy to search and easy to read, and digital data is easy to store. It does require electronic security. You can have corrupted files, which would be awful because you could lose that data. So it's nice to have backups of your data in different locations, either on different hard drives, or maybe keeping every once in a while print out a copy and have a hard copy located in the lab. Okay, so you also may have some software compatibility issues over time. This can happen especially with different equipment that you might be using. So what should go into your notebook? Your notebook should have a name. So if you're in a specific class and you're using that notebook for the class, that could be the name. And then inside the cover, on the cover page, you should put your name and contact information. That way, if the notebook is lost, somebody can return it to you. You should also put in the year that it started and the general project name that you're going to be working on, if you have a specific project. For a class, you may have a number of different types of experiments you'll be doing. Then you want to save out the first few pages for tables of contents. Right? And then after the first few pages, then you'll start the body of your notebook with your experimental entries. Each of these should be dated. Okay, so this is an example of a table of contents, right? So each number in your notebook should have a number. If it doesn't physically have a number, you can put numbers up there in the corner, number 1, 2, 3. You should also always include the dates when you start different experiments. And then the subject and the experiment. So in your table of contents, you want to have specific things that would make it easy for you to go back and find different things. So if you're doing a new method or a new experiment, having the names in there will let you go back very easily and say, oh, okay, I want to grow some more DNA to extract. That was on page 7 and 8, and I can go find that protocol very easily so that I can repeat it. For each experimental entry, you want to have the date, the title, your hypothesis or goal of the experiment. This can be brief, just a couple of sentences. If you have background that you need to include in there, that would go next. And then you'd have your protocol, calculations, the reagents table, equipment that you used, and then observations. So all that happens, whatever you planned or unplanned, always include your raw experimental data. It always has to go in there. So if you're collecting a lot of data points, say by spectrophotometry or something like that, you want to have a table that has all of that raw data in there. Don't just put in a graph and not show the data that you used to create the graph. Taped in information is you can always tape in graphs or tables into your document. So if you do something on Excel, for example, you can print that off and then tape it into your document. If you've got an electronic document that you're keeping, you can copy paste it into there, or make sure that you reference where the data is located in the lab. So if you have a hardbound notebook, but you're keeping data files on the computer, then you would have the data files in a central computer database that could be accessed by your lab. But it's always good to have the information, when possible, in the actual notebook so you don't have to go searching around for everything. Then you want to do the data analysis. So this would be the processing of the raw data. So this would include your graphs, any interpretations that you have of the data, and this can be written interpretations in the conclusions of those interpretations. And then any ideas you have for future experiments or conclusions about what went wrong. So maybe you had something unplanned that happened. The incubator wasn't to the right temperature, and so you did your incubation at 5 degrees less than you had planned to do, something like that. So that you know when you go back, if it didn't work, what you want to change for the next time, which will give you the ideas for future experiments. Yeah, so you are learning that experiments are experimental and they don't always work. Even the ones that we've done multiple times in the lab, sometimes a reagent's gone bad or the instrument's not working correctly, and this can happen, and you've got to kind of roll with those punches and keep going forward. So if your PhD experiments all work the first time, you'd be done with your PhD in 6 months. But instead, it takes about 5 years. That's how many times you got to do your experiments over. Okay, so here's an example of a laboratory notebook entry. Take a few minutes to read through this. All right. So hopefully you are thinking a little bit, what is going on here? Right? So now think about this in the context of evaluation. You're coming in looking at this experiment, and what if I asked you to repeat this? Could you repeat this? Do you even understand what they're doing? Is this a good notebook entry? What's missing? Right? So you can take another look here and say, hey, what is missing? What else would I need to know? So I think when I'm reading this, treated samples of Nostoc punctiform with UV light, okay? So they've given me kind of what they're doing. That's very brief, but okay. But they don't say why. They don't say what they're expecting to get from it. Or what they're hoping, they're doing this experiment for. So there's no real purpose statement, and so a purpose statement would be nice to have in here. What do they say next? For each treatment, I used 2 liters of culture placed into a 6-inch by 12-inch Tupperware. The depth was about 3 inches, and I used 2 separate stock cultures for treatments. The first culture was control light, 24, 48-hour time points. And one culture was the control dark with 72 and 96-hour time points. This is a little bit unclear, right? So we've got a depth of 3 inches, but it doesn't really say what the culture is, so we don't know what's in the culture. I mean, other than the Nostoc punctiform, we don't know how to make the broth to actually grow the culture. So that's actually missing. That would be important to have in there. Okay, but at least we have the amount and the depth. And then it took 1 month to grow the cultures up prior to treatment with UV. Treated samples sequentially since we only have 1 UV lamp. Okay, but there is no measure of what those cultures look like by the time they're ready to treat. How dense are they? Are they colored? What do they look like? It would be good to have that information in here as well. For each UV treatment, both the UV lamp and a white light were placed inside a cardboard box with the Nostoc sample. The UV light is UVP brand UVM18 EL series with 302 nanometer UV 8-watt bulb. So that's good information. We could repeat that UV exposure. Samples were exposed at 5 inches away from the source. A white light, Light of America model 7110N, was also suspended at 18 inches above the culture. The samples were incubated at 28 degrees during growth and exposure. Interestingly, I noticed that the algae were mostly floating on the surface of the water prior to exposure to UVB. However, at the time of harvest, they had all sank to the bottom of the Tupperware. Could this be to try to escape the intensity of the UV light? Could they be dead? I don't know. Okay, but there is some observation there. For next exposure, to get more uniform UV exposure, I should use less water to culture ratio and find a suitable rocker to distribute the mixed cell population during the treatment. So there's some nice what to do next time, thinking about what I observed during that experiment there. To harvest the samples, they were spun down at 3,500 RPM, and the supernatant decanted back into the Tupperware where it was allowed to evaporate to dryness. The pellet was divided into 2 parts. One was frozen back at minus 80 degrees for RNA analysis, one that was extracted exhaustively with methanol until almost no pigment remained in the cell pellet. The crude extracts were resuspended in 1 milliliter I didn't say of what, so I should have said methanol, and analyzed for their UV-Vis absorbance spectrum. Unfortunately, the printer was broken and I was unable to print the spectrum. However, there were no visible differences between the control and treated samples. You'll notice the raw data is not in here except for a few of the experiments. So there were noted some differences in the 72-hour sample with control dark. So it would be good to have the raw data all in here. Or if I have it printed somewhere else, but the printer was broken, so I probably don't, then you would say it's in this notebook or binder somewhere else. I also ran out silica TLC samples in 3 different solvents to look at the profile. I didn't see striking differences, okay? And the solvents are all up here, so I do show what the solvents are that these were run in. And you can see the samples didn't run very well in this one, or stain well at least. They ran out more here, and they ran out the best in the 9:1 chloroform methanol. Stain samples using anise sulfuric acid. I should have written out the how that's made, or at least what the concentration of these 2 components are and what the solvent is. So that's not good. All right, and then set up doing the next extraction. All right, so you can see there's a lot to be desired in this example. That was my notebook from my postdoc. So you can see I'm not perfect either, but there's not enough details in there. Even the abbreviations aren't given. Growth conditions weren't given. The recipe for the TLC stain is not given. The raw data is not in there. There's no purpose. So you can go on and on. So, you know, when you're making your entries into your notebook, you really need to think about all the details that someone else would need to be able to pick up your notebook and repeat your experiments. If you don't have enough information in there, it's not going to be helpful down the road. All right, so that is a good example of a laboratory notebook entry. Well, I don't know if it's a good one, but it's an example of one that has some flaws in it for you to look at so that you can see what a not perfect one is. And coming at it from the standpoint of thinking about if you wanted to use that entry to try to repeat the experiment, I think the one that you just saw would be medium difficult to repeat it just the way that I had done, especially with the growth of the cyanobacteria, because I didn't put anything about the growth media, what that was made of, or how dense the cultures were once they were grown up. All right, so moving to the methods section of a paper. Again, this is written as a narrative in past tense and in the third person. Okay, so there's a couple of videos in here, and we're going to jump to those so that you can take a look at these guys.